Hello, everyone, and welcome to our fifth session in a series of AI learning. This has been a 6-week amazing journey that we will be continuing for one more week, and you will have all the content and everything interesting for you to go through in your Christmas holidays. And if you don't want to, just go through now, and you can enjoy your holiday period as well. So today's session is about AI agents. So we are continuing from the previous session where we talked about a single agent and how agents can do multiple things. Today we are going to talk about multi-agent system using Google ADK. Next slide, Sonika. So it's just an introduction what women coding community is about. So we are a community where we build a safe and an amazing environment for women to thrive in tech through education, mentorship, and community building. We do a lot of workshops and events like these, and we are a very supportive community. One of our very popular programs is a mentorship program, and if you are not part of that program, if you're hearing it for the first time, I think you can enroll it in the next year now, and you will be having an amazing set of mentors in the new year as well. Just on a note that what is our code of conduct. So there's a link. I can share it in the chat as well. You can go through. If you want to get involved with the community, you can join our Slack channel. Go through our meetup links where you'll find all the details about our upcoming events. Like there are a lot of events we'll be having this week. So this week is quite a popular and a busy week for us. Like we have tomorrow, we have a event from volunteering with a coding club that is in partnership with Raspberry Pi Foundation. At the same time, we have another end of year celebration in-person event on Friday. So if you are interested in any of the events in future, so just go out to our meetup and you can find all the details about the events. Next slide. So this series has been brought to you by Sonika and myself. Today's session would be given by Sonika, and she's going to share about multi-agents and how you can use all the details, and she's going to give you a detail around how to build multi-agent system using Google ADK. That's it. Over to you, Sonika.
Thanks, Sonali. Okay, so hello everyone. So today we'll be talking about multi-agent systems, and let's talk about the journey a little bit. So we started with LLM APIs and SDKs, how to call AI APIs. Then we talked about how to generate good prompts, some techniques, some security mechanisms for prompt injection. And then we talked about RAG giving external databases on up-to-date information to your AI APIs, and then single agent systems. And today we'll be talking about multi-agent systems. So let's look at the agenda quickly. So we'll talk about why of multi-agent systems. What is multi-agent system? What are the mechanisms available in ADK from Google, and why Google ADK, and some of the internal hierarchies which we can follow in multi-agent systems. We'll talk a little bit about MCP and A2A because those are like the foundations if you want to talk to other agents, and some resources later on with the demo. Right. You can raise a hand anytime you want to ask a question. So, yeah. So this slide I wanted to add, which is also a recap, but this is how it evolved to multi-agent systems. So you had just an LLM and a prompt. So you had the model, you're just calling it, asking for information. Now it can't do anything, it's just there. And then you have retrieval, augmented generation, the RAG systems, which we talked about as well. And then you have action. So you have LLM, you have external system, then you have tools which can do something based on the information coming from both of these. And then you connect them all together and then make a reasoning loop, and which is the agent. And then you have multi-agent systems which talk to each other, and we'll talk about it why later on. So I wanted to recap a little bit in detail about AI agents, because that is the base I'll be following as well today. So let's look at this. So as we said, so you had the model, and your model is the brain, right? So you used to talk to in chat boxes, like, you can talk to your LLMs. It'll give you a lot of information, but you don't know how to process it. And then you have tools which can act on behalf of you, and it could be databases as well. So something extra other than that brain. So you have different tools, and then you have the reasoning loop, which make sense of both of these together and give you something which you want. I'm going to go a little bit detail into tools and reasoning loop here, and look at what tools we have available. So model could be, it's the brain, it could be anything. It could be a local model, it could be a foundation model, so generic model, it could be trained domain specific model. So whatever suits you, you use that in your agent. Then you have tools and reasoning loop. So let's look at the different type of tools. So tools could be APIs. So, earlier in the start, when we started talking about AI APIs, we said, don't use it for deterministic tasks, but we have moved a little bit beyond that. So we can also do deterministic tasks using LLMs as agents. So you can call APIs, which give you good information. So if you have something already, you can use it inside your agent. So example is like, you already have a booking agent or something, you just pass information to it and it will book the tickets for you. And then you have functions. So functions is basically something local. So you wanted to add something, as an example, so calculations, things like that, which are very local. Your information is not going anywhere. It doesn't need anything extra. So something which was a function for us, like as a method in your code. So that's another way of providing tools. And then you have data sources. Data sources could be databases, could be rack system. Most of the time with agents, they are rack systems. So you can have like, you can have some sensors or something, so lots of data, and it can make sense out of it. So it gives an example of stock prices and all, customer information. And the fourth type is the plugins. So plugins are like, you want to send a message to Slack from your agent. So things like that, they're not actually APIs, but they can be, you can still interact with them. Plugins can also be payment gateways and all, which are not directly APIs, but they can be connected to your systems. So let's look at the whole reasoning loop. So I'll give you an example so you understand it better, that why it is not traditional system. So you, for example, you ask your agent to book a ticket for you, or a flight ticket, and you want to go with the flights which are compliance with your company policy. So you have two tools you need here. So you need a compliance tool, and you also need a search tool which can search flights. You can also have some restrictions on the prices and all that. So your reasoning, so this reasoning loop will select the tool. So you ask this question in natural language. It selected two tools for compliance and for search of flights. Now, what happened is you got the result back from, after execution, you got the result back for the flights, but your compliance tool failed. Now so there is an iteration here. So it goes back to the reasoning. It observes, goes back to the reasoning, and it checks, there is a failure in one tool. What should I do? So what it does is it looks at all the flights, choose the one which are suitable. For example, if there is a price filter, So it only send compliance requests for those flights rather than asking it for all the flights, because it knows it's failing or timing out or something like that for extra flights. So it will make the decision on itself until it gets the result what you ask for. So it will keep on iterating in that loop. So that's just one way of processing information with agents. There are different ways. For example, you can have a chain of thought. You can have a tree. So based on that, so this is React. So based on your structure, whatever reasoning loop you have chosen, your agent will work on that loop. Now, do you have any questions till now about the single agents? Right. So can anybody tell me why would we go with multiple agent if we have everything which can be done with this kind of execution? You can type in the chat. Yeah, go ahead.
So just thinking, since you mentioned multi-agent is a single agent interacting with each other, like three single agents interacting with each other. So the explanation you give here for a booking of a tour, probably I also want to reserve an hotel. So my agent for booking my tour, my flights can also interact with the one booking an hotel. So it's, how would I put it? It's more of a systemic process rather than just one thing being containerized in one place. Thank you.
Yep. Nice. So yes, parallel work, somebody mentioned. There are like certain reasons other than that as well. So you want specialized agent which only do like one task. So that is one of the reasons. The other reason could be, so let's look at the reasons I have listed here. Okay, so your context is too big. So you asked for two things. It has multiple tools. Every tool is doing its job, which is fine, but it still need to manage all the context. It need to manage did compliance happen properly? Did the search result came back with something? Is it any useful? Should I look for other websites or something like that? So it's too overwhelmed, and we're just talking about two things. There could be hundreds of things, and sometimes we give like 100 tools to one agent, and it's like confused. It doesn't know which one to call when, and something fails in the whole process, and it's so hard to figure out what failed. So basically, it's like a lot of context for one agent to manage, one model to manage. The other one is journalist trap, which is basically you wanted something domain specific. So you can have, if you have two agents, you can have one running on foundation model, which is the generic model, and other one on a domain specialized models. So, or you can have local models if you don't want to pass your information on in an API. So you can have different models running on different agents. And then obviously we talked about debugging. So if there are different agents, you can debug them a little better than before. Then it also reduces hallucination risk because your context is managed. And we'll talk about how it is managed in coming slides. And the biggest one I haven't mentioned here is the cost. So from business point of view, so it actually ties with the second journalist trap. Basically, if you call foundation model for every small thing, and so the cost stacks, and then your context cost also stacks with that. So it's very costly to have multiple tools and calls, LLM calls happening in a single agent, which can be easily done by smaller agents and smaller tasks. So I'm going to go the other way around. So looking at what is the advantages. I'm talking it first. I should have done it later, but because, so it's the other way, the other side of the coin. So you can have expert mode. So you can have researchers, you can have writers. So if we talk about an IT team, so you can have QAs, you can have BAs, you can have coders, developers, architects, so specialization. Definitely. And then you can decompose a task. Nobody needs to know. So QAs don't need to know what devs did or how they did it. We can just decompose the task between all the agents. And then it gives us this modularity, which is similar to like, like we have APIs these days. So you can have different system and agents which can be reused in other agents. So yeah, so it gives you this reusability part. And emergent behavior, we'll talk about it in a bit, but basically you can do complex tasks by dividing them into smaller tasks. So this is how your multi-agent system will look like. So you will have a root agent, and you can have, you want to book flight tickets, but you want some ideas, so you'll have an inspiration agent. Then after that, you can have a planning agent, you can have booking agent. They could be running parallel or separate or one after the other. So this kind of hierarchy we can achieve with multi-agent systems. So this one we talked about. So decentralized. So this is like the basic features of a multi-agent system. So we decentralize the control. No one agent is caring what the other agent is doing. It only have its own memory. It knows what input it needs. It only has the tools it needs to do its work. So it doesn't care about anything else. Then you have local views. Basically, sometime you have designed your agent systems in a way that, so if you look at this previous slide, in this one, you will have planning agents. So flight search assist agent can see maybe weather, but it can't see what this place agent is doing at the top. So it will know, so this yellow one will know about each other, the green one will know about each other. So this is basically local views, but it won't know what is happening at the top or in the other agent groups. And the last one is emergent behavior. So this is like very human behavior, basically how we work these days in teams. So you decentralize, you give different roles to different people. They do their own work. They only know what, so devs will only know what QAs will test. QAs will only know what devs will develop, but they don't know how it is done. And then finally, at the end, you will have this working project or a product. So this is kind of like in real world scenario. So this is the emergent behavior. Now, if we talk about what kind of multi-agent systems are there. So the most instinctive one is role-based. So you know these are the roles I need. I need a researcher, I need a writer, I want somebody to check the syntax and grammar, and I need somebody to check the compliance of the report. So you have different roles. So you can have role-based agent. They will there'll be a supervisor agent which will talk to them, but they don't know what the other person is doing, and you can run them sequentially or however it works for you. So that's the role-based one. And then you have this competitive multi-agent system. So first time I used LangGraph, I did this thing. So what I did was I wrote a blog and I wanted to write a Twitter post for that. And I wasn't happy what it gave me the first time. So what I did was so these are just 2 steps I'm mentioning. So what I said, can you read this Twitter post and go back and regenerate it until it is this level, so this rating or whatever. So it will keep on looping until there is this and so either you can have number of loops, so you can say, okay, 5 times do this, or you can have some cutoff thing, you can have some condition present here, and one that is met, it will go to the evaluator, and evaluator will check, and then it select which one is the best one, and then that will be the final output from that multi-agent system. So this is very useful in some of the systems. We'll see some example later on. Then we have cooperative, where they are working in parallel. So you have multiple agent. Sometimes they're doing the same task, and at the end we will just merge the output together. It's not like this evaluator one, but little similar, but it works in parallel, not sequentially. So yeah, So it's cooperating with each other, and sometimes they can also see each other's states, memory. And then you have debate based. This is actually a evaluation pattern. So what happens is each agent will have an evaluator critic. So whenever an output comes, the evaluator agent will check if this is good enough. Is it according to compliance? Does it have facts? Does it have any hallucination? So every output is checked by another LLM. You can have a different LLM, or you have the same one, whatever works for you, or you can have a specialized one here to check the output. So this one is a little bit expensive, but if the consensus, the end output will be much, much better than the first one. You will see. Any questions till now? Any other type you can think of? All right. Let's go to the next one. So this is now ADK. Sonali gave some information about the basic of ADK last time. So ADK is Google's agent development kit. It's an open source. And we talked about multi-agent systems and the different ways of designing it. And ADK provide ways to do all of those things internally, and evaluation and deployment. So everything is available here. So there's the base agent, and it gives you different types of agents. So first one is the LLM based. So LLM based is the one which can reason, and so it will have tools and everything. Basically, the decision making is happened using a model, basically. So that's LLM based. So basically one single agent. So now you can have workflow agents. So workflow agent, you can have sequential agents. So all these behaviors, you can, for example, if this is a loop, you can do loops. If it's parallel, you can do parallel, and you can do sequential. So whatever works for you. So these workflow agents are available. And then there is custom one. So now you don't want to call an LLM and you have your own code written somewhere, which is not LLM based. So you can use custom agents. So basically just extend this base agent available in ADK. So you can do anything. Basically it's code. So you can do whatever you want to do. That'll be your custom agent. Okay, let's look at the code a little bit. So if you see, this is how you write an LLM agent in ADK. So you just extend this LLM agent, you provide which model you want to use, give it a name and description and some instructions and the tools it will need. So now, if you think about it, if your LLM is the brain for an agent, what is the devs going to do? They need to decide all of this. The description has to be really good. It should know what this agent is for using its description. And instruction will tell you, what is it's supposed to do. So here it's searching the Google search. So it can't do it on its own. So I have to provide a tool. So ADK also have Google search as a tool. So you can just say, as Google search. So it can search things for you. Very generic agent here. So one single LLM agent. Now this is how sequential agent will work. It looks pretty easy to see, but if you think about it, so you have to manage the state between these. So even if your tool are like APIs and all that, even if it's like stateless, but agents are not stateless, they need to maintain state, otherwise they can't make sense of the output. So this sequential agent will pass on the state or the memory or whatever, however it's saving the context to the next one. So this is an example of a sequential agent. So this is a pretty good one. So if you see, the name is called a pipeline, coding pipeline. So somebody is right. So there is an agent called code writer. Then there is an agent which is a reviewer. And then after review, you have refactor. So you can't do it parallelly. You have to write the code first. Then you can review and refactor. So this will run sequentially. So you can use sequential agent here. Now it's okay. Let's talk about that in a bit. Let's look at the next type. This is the loop agent. As I mentioned earlier in that type of multi-agent system, so a loop agent will have multiple steps and they run sequentially but in a loop. So after the last one is running, it will run the first one again until some exit condition is met. It could be number of iterations. So I said max 2, so it will run only twice, 2 times, and it will give you the output. And if you go to the code, so why would you need a loop agent? So we talked about critic and refiner. So somebody has wrote something and there is a critic agent, somebody will refine it, and then it goes back to the critic agent. And I would say, okay, 5 times max. After that, whatever is there, just give the output to me. So this agent work like this. Parallel agent, pretty simple. So same way. So they will run in parallel with the same input, but they'll all give you different outputs and you can do whatever with that output. Let's look at the code. So you have parallel agent available in ADK. So you can give it a name, a good description, and then you can say, same research given to different agents. Maybe the agents have different models or something like that, and they can run in parallel. Now we talked about all of these. What else you think we can do except these and the LLM and custom agent? Any ideas? I mean, when we talk about some systems, we say, okay, this is traditional and this is the new way, modern way of doing things. But there's always a hybrid. And I love hybrid system because that is what real problems are solved the way. So basically, you can have parallel agents. So this is sequential agent, which is running a parallel research agent first, and then it's running some merger agent. So you can also have a loop agent here. So you can all tie them all together and make your own pipeline. Now, the question here is, if you have to run agents in a certain flow, why can't I do it with traditional systems? There also we had workflows and all, but the main part here is that the decision making is still done by your LLM. So with whatever is the supervisor or whoever is handling all the states, it's done by them. So it's still pretty automated system. So there is an autonomy. It can make decision on its own, even if you have given a sequence of steps. Now, if we have talked about this, and the next important part is how we pass the state to the next one in that workflow. So there are like certain ways of doing it. So one is shared session state. So you can maintain a session dictionary. So you in your talk you said, okay, so I'm booking a flight to this place, or you are asking for ideas, and you can say, oh, I like India, so that will be my favorite. So it will save it in a state, in a dictionary, and that state could be shared with other agent if the supervisor think it's useful. So in this state, so you'll have like one shared state, and all the agents under that main agent can access that shared state. So that's one way of doing it. And the other way is always LLM driven. So your LLM will decide what to share from that state to the next agent, or whatever agent needs that state. So it will reach that memory through LLM. So LLM will decide that. So there is this handoff happening, and LLM will, so there's an extra call here. Now, this one is actually the same thing, but this is where you are using your agent as a tool. So basically, you have different agents. You can also use agent as a tool. So one agent can be added to the tool list of another agent. To achieve that, there is a way where this agent tool, it's basically class in ADK, can be used. And this one is a little different than being just an agent, because in this state, in this case, it will, along with the input, it will also pass the state to this agent. Generally, the handling of the state is happened using the supervisor, so it's happened differently. But in this case, it's using it as a tool, so it's pretty useful. If you So I'll talk about A2A later, but if you're talking about some agent which is not in your system, it's deployed somewhere else, it's remote, you can use it as a tool and pass the state here. So it's pretty useful in that way. Any questions till now? Okay. I'm going too fast, or is it okay? You can, okay, cool. Now MCP, it's quite famous if you haven't heard about it yet. So people love using MCP tool. So it's any tool you're using, any IDE you're using, you can have MCP connected. So this is a way of giving tools, external tools to your agents. And this is basically a standardized security protocol. So you can plug in your external systems like Jira or Slack or whoever has given its own MCP. You can even write your own MCP server and do whatever you want to do with it. And you can connect your external systems to your agents. So basically, it maintains a secure it's basically a security protocol to connect to other systems. So it's now the important part here is we can have a different session just about MCP. So it's quite a big topic. So basically, the important thing to know here is it's not a one-way flow. Your data transfer is bidirectional. That is why security is so important in this. So if you want to look at a calendar and book an appointment, so what you do is, okay, so I want to book an appointment for this thing. You go to the calendar, check it, come back. Okay, these are the free slots. Then it goes back again to book whatever is suitable based on your agent. So they're like pretty much anything you can do with this these days. So MCP is very useful in agent-to-agent communication, multi-agent systems. Now the second biggest one is A2A. I kept it for last, and it's if you haven't heard about A2A before, so this is a protocol from Google which helps you connect to remote or local or other agents. So basically there is a contract which you need to give to your agent, and that contract will list what is the agent, what it can do, what are the tools available, what the tools can do, what input they need and output. So it's basically everything an agent can do, provided to another agent in a secure way. So it handles the authentication. And internally, you can also have MCP connected. So as you can see in this diagram, and I will show you an example of how A2A works in the demo. Yeah. So MCP is from Anthropic, if you don't know, and A2A is from Google. And there are lots of new protocols coming up, like payment protocol, commerce protocol. So there are lots coming up now, and ADK supports most of them. Okay. That's actually kind of the end of it, but let's look at the agent engine in Google Cloud. So this is basically the whole ecosystem. We talked about single agent, multi-agent, we talked about LLM. So if you see, you have this agent space, which is it's a workflow design system. So you can drag drop agents and connect them however you want to do in a visual way in agent space. Then all the agents which are available here are registered in this agent engine. So you can, when you deploy, they are registered somewhere, so you can search which agents are available to you from that system. So basically you should need a way to do that. So this is how you do it in Agent Engine. And then Agent Engine can work with pretty much any agent SDK or platform. So you have ADK. So this is like, because it's from Google, it's supported everything out of the box. For LangGraph, LangChain, you have to make some changes and do it manually, but you can still deploy all these systems, add it to Agent Engine so your agent space can search it. You can also have remote ones registered here. And then, as I said, you have A2A available, the agent to agent protocol. Then you have tools. There are lots of built-in tools available, and there are like so many. And then you have custom tools. You can write your own tools. You have ecosystem tools, external, internal. Then you have Google Cloud's own tools. For example, if you want to talk to BigQuery or something else in Google Cloud, you can do that. Then you have MCP. MCP also have its registry, so everything which has registered as MCP will be also available to you as tool, and then they're open tools. And then a model, obviously. So there's a model garden. You can choose models from there, and you can also have fine-tune models there. The next session will be about evaluation. So there is evaluation available if something is deployed on Agent Engine. So because we're talking about ADK, so we will talk about this evaluation. And there is observability. Something breaks, what do you do? So you have tracing, logging, monitoring, everything available here. So this is the whole ecosystem. It's expanding every day. So this is like from last month, I think. Might have changed. I don't know. Okay. Now I wanted to mention it. So if you have some time this month, Google is running this no-cost AI learning on Google Skills. You can copy this link. I can share it later if you want in Slack. So this is pretty good. So you can do lots of labs and lots of learning for AI. And there's pretty much everything related to Gen AI and agents is freely available. So if you have time, please make use of this. That's it. Anybody has any questions till now? Or was it so easy? So we have talked about some of the stuff which ADK follows, like the workflows and all. If you go to LangGraph, they'll have their own, but most of the time they follow the similar structure. So I don't think there is anything other than this in terms of workflows you can do. There is a lot of things you can do in terms of memory and context management, and also talking to other systems and tools. But pretty much this is the standard way of doing things. All right, if nothing else, we'll go to the demo. So if you haven't done the single agent yet, I would encourage you to go and see the single agent first. So it's available here. I have expanded on top of what was already in the live demo last time for mentorship. How to manage the memory for each session? Very good question. So basically, there are different ways of doing it. So ADK as a platform for you to build agent does it internally. So if one session is running, it will make use of that session and it saves the state automatically. But if you want to handle something custom, then you have lots of session things available. I'll show you in a bit. And you can also have like session instance, if you want to like save it locally and see what's happening, you can also do that. So there are lots of ways of doing it. Okay, let's look at the code. So this is how it looks like. You will have so if you see, I'm gonna close this. This is a live demo. I tried few agents. You can go have a look at the different ones. So basically you need this agent for sure. This is the main one. So if when you run ADK web, it goes to this. If you're running ADK first time, you can also say ADK create and some agent name, and it will create this whole structure for you. And what it does, it will have some agents. So this is my root agent. Let's look at the documentation. Wow, slow. Okay, cool. Let's look at this. So you have a mentorship coordinator here. It's running on Gemini 2. And it has this information available. You can pass it as a file or whatever. Quite big. So it has everything listed, like what are the things it can do. So these are all the tools. So some of the tools are like backup tools. So if my actual tool fails, what should I do? So there's so many which are like, so there is one which is like local. So basically, whenever you're running an LLM, always make sure that your agent have backup for every tool or retries available if it fails. So these are the tools. So this is what is the state management tool I added at the end. And let's look at this, what it does. Yeah. So this is how you manage the context. So there is a tool context and you can add state to it. Now, right now, I just saving everything which is in the state. You can also compress it, or there are different ways. If you want to shorten it, make it smaller. So this is remembering some of the users I will ask about, some of the sessions I will ask about, my favorites and things like that. You can save. Then these are the intake tools. So I can save profiles, read guidelines, list profiles. There is a verification agent. Let's look at this one. Okay, so verification is just a call. So it just checks the LinkedIn. So it's not basically, it's not an LLM agent, but it's provided it as an agent here a tool here. And we can also match mentees, and we can find mentors by skills. And I wanted to show you this one. Now, I am using the actual website here as a source. And this is just because I didn't have any API for the mentor. So I'm just using an, what do you call, this, if you have heard about it, it's beautiful. So it's an HTML parser. So it's a scraper basically. So it's finding the names for the mentors. So these are the tools. Now, you can have multiple agents, and let's look at the other agents. So when you have A2A, so how does it work? So in A2A, I have these 3 agents here. So one is the intake one. So when I say, I can deploy it separately on a different server. I can deploy it in AWS or on a cloud run in GCP. And when I'm searching for this in the registry, this is what I'll get. So based on this description, I would know if this is useful for me or not, or should I use it as as my multi-agent step or something. So basically, it includes a description, the name, versioning, capabilities is basically what it can do in terms of, so this is mentorship. So it can do save mentors, match. So basically this is intake. So it's just saving, read some things and list. So these are the basically capabilities are the tools available to it. Now you have a matching agent. It can find mentors by skill. This is the tools available here. So for tool also you give description, input, output, everything. So basically it's like, like in APIs, you have that schema. It's just a schema for an agent. And it's very useful when you deploy it. And sometimes it also will have some kind of security things available, like how to use this. So this is an agent card for it. So then we have verification one. So it verifies, this using this LinkedIn URLs, if this is a good match or not. Or you are for if you want to be a mentor or mentee. So it verifies that. Okay, let's run it. This is for the main agent. So this card is for the main one. I'm going to run it. So when you're running it and you have this agent pipe, you need to go a step outside and do it. So you can't do it when in the same folder. So I'm going to go, okay, I'm already in live demo. Okay. So for local testing, so if you see it's just a web interface, so you can deploy it easily as a website if you want to. I'm going to go and open this. Now I'm running it from one directory above. So I had like multiple agents. You can like choose the one you want to select. So I selected this. I didn't have time to put a welcome message here. So I'm going to directly go and do something here. So I added an event agent there to search for events, because before mentoring, I want to see what is happening. So I'll ask for the events at WCC. So now, if you see, this is a tool available to it, Google search. So it's going there. And then basically I gave this URL. So using Google search, it's going to this, getting the events. And if I expand on this, you can see what happened. So something fails, you can go to these conversation and trace it back. So it's giving me that there is a book club. Okay, these are old events for some reason. Let's ask for will it work? All right. Okay. I'm pretty sure it picked up events from here, but anyways, let's look at the mentorship program. That's why this was written. So now this information is coming from this link. It's giving you the source as well. And it's saying that the ad hoc happens every 10 days of first 10 days of every month. And now the cycle is closed. Sorry, 2020 cycle is open. Wait a second. Okay, yeah, it says open. I thought it's closed now. Okay, that's fine. So now in terms of demo, it just will, I'll just show you how different tools are called. And now if you look up, okay, I think we didn't look at, okay, let's finish this one first. So from the local database, it's finding this because this was my backup from the WCC website. For Python, these are the mentors, but they're not available at the moment. So I will check. Now it has some mentor details, so it can answer you different questions. So if you look at this, no tool was called here. This was a direct LLM call. So it can decide some of the stuff on its own. And I can directly search. Let me see if there are some mentors available. Now it will go for the tool. Yes, it searched the web, went to the tool. So nobody's available. Okay, I think it's the end of the year. So now you can see every tool call here. You can trace it. So all the invocations are available. And I'm not saving the state intentionally at the moment, so it's not saved. and no artifacts, but there is a session. So in the session, okay, there are no evaluation. So you can also have evals and everything here. We'll see next time. So basically, this is the main thing. And from there, you can see if something fails. Now, I think there are like other agents where you can evaluate. It'll ask for lots of details as Sonali did last time. So emails and goals and availability, and then matches it on LinkedIn link you will provide. So things like that you can do. So basically, the main thing is think of a use case, see which things should be tools, which things should be agent, and why they should be, because most of the things you can also use as tools. So make very specific agents. They should have definite rules, or you should have like maybe you're using different models, or they are working as an agent judge or something like that. So in that case, you'll have different one. Otherwise, you can just go through this and see how to make it. And I always say, okay, let's look at the preview if it's open yet. No preview. Okay. I'm just going to open the file. So this is how it looks like. So you have 3 agents: intake, there is a web search for available mentors, and then you can save after you. So this is another agent for saving. So when I say, okay, I want to join as mentee, it will save my information. Right now it's local DB. You can have a RAG or an external database connected here, and you can save it anywhere you want to. So basically, this was a parallel agent. You can also have sequential if it's research and writing. I wanted to show you the ADK documentation. Now, even if you use a AI to write this code, the syntax changes very fast. So I wrote something, I had to change the whole thing again because now the syntax is different. So always look at this. It has everything you need. There are lots of videos, lots of diagrams, which will make you understand it better. So we talked about this just now, multi-tool. In multi-tool, we talked about, so it gives you all the step-by-step instructions. So I didn't show you this time because we did it last time. So you need to install ADK. And then this is the structure if you are following. I mean, it should be a different folder. It doesn't have to be the same name, but you create a directory and then you put all your agent in that directory. So things like that you can see here. And I'll show you what we just talked about. We talked about different kind of agents. We talked about this. LLM agents. It gives you lots of syntax and options, how to use it. Then we talked about workflow agents, sequential loops and parallel. Then we talked about custom agents. We didn't talk about a lot about agent config. So this is a little bit advanced. So we'll talk about it next time, and authentication and evaluation. That's it. That's all I wanted to show. So just search for ADK docs and you can find this website. Thank you. Let's go back.
I think I have one question. How
Yeah.
do I handle errors?
So basically, as I said, you always have retries in your loops or wherever. So each agent will have its own retry. And sometime when you're talking about React, the reasoning can handle a lot of things. It will know from the error that it should retry or not. Like, you know, in old systems, if I give retries, it will always retry. But in this case, based on the error, it will check, should it wait for some time? Should it call directly, or is the input wrong or something like that? So that way you can handle errors. So retries is one way. The other is the backup. So if LLM is not working, what should you do? Should you have some kind of function calling, like tools available, something else? So maybe one task can be done in like 2 different ways if LLM doesn't work. So that is another way of handling it. And then, yeah, so based on how the structure is designed, there are some errors which it can handle itself. the multi-agent system. Does it answer your question? Did you ask in terms of Sonali? I can't hear you.
Yeah, I think it was a question on the chat, but yeah, I think she did the thumbs up. So yeah.
Okay, cool. Anything else, anyone? We have 3 minutes left.
Okay, we can just wrap up with the what we are going to have in the last session of the series.
Let me share this again. So yeah, it doesn't have much. It just Google AGK and the code. So the next one here.
Yeah, I think as shown on the screen, we are going to talk about LLM evaluations and ADK agents deployment in the next and the last session for the series. All the resources that we have captured on these slides, I've tried to add it on a canvas on the Slack. So if you're not on the Slack channel AI learning series, please add yourself. It's open. Anybody can join it. I'm just posting that Slack channel details here as well. You'll find all the other details about the GitHub repo and other details about the series, what we have done so far, and the YouTube channel where you can see all the previous recordings as well. So if you still have any questions, please drop a message on the Slack channel and we'll be happy to answer. Thank you.